All right. So this last chapter before we get into Thanksgiving break is all about inequalities. Okay. I don't know what your previous knowledge about an inequality is. They are unequal. Okay. So we're coming out of equations, which obviously are two statements that are equal to each other, into statements now that are maybe unequal to each other. So we have to take out what from an equation to turn it into an inequality. Like what's got to come out of there?
Like, what do you take out?
Yeah, what are we removing?
Equal.
We're taking out the equal sign and we're going to replace it with. So it could be a greater than sign, it could be a less than sign. Okay. So I want you to think for a second, how many inequality signs do you know? So kind of be thinking about that. So as you're getting your notebook out, as we're going to start chapter 5 here, all right, think about how many of those symbols maybe do you know? Today we're only going to look at two ideas. How do we solve an inequality with addition, or how do we solve one with subtraction? So the math is not going to be difficult today. All right, that part should not be a problem for us. If we were going to look at something from last chapter, you should be able to give me an answer to that in like 2 seconds, because everything you need is already there. What do you got, Faith? It's got to be B, right? You got to know your slope, you got to know your y-intercept. So thinking along those lines, okay? But as we continue to move here today, these are our two goals. How do I solve by addition? How do I solve by subtraction? Okay, tomorrow, obviously, then we'll look at how do you solve by, what do you think? Multiplication and division. Okay, so those are really your four ideas. Okay, all right. Something we're going to get into today that you probably have never seen before is what's called set builder notation. So we'll talk about that when we get to that point. All right, I would put some good money you've never seen it before. All right. So Brooke gave us basically this statement, right? That an inequality is two things that are not equal to each other. James gave us two answers already. He said it could be filled with a greater than or a less than. I asked you to be thinking, do you know any more inequalities? What do you got? Good. And if that line is underneath the greater than or the less than, that really means. Okay. So now we're up to four. We have a greater than, we have a less than, we have a greater than or equal to, we have a less than or equal to. Now, equal would not be an inequality, it would be an equality. So we're at four right now. What did you say? I think you're right. Sure. Well, if you saw anything with a big slash through it, what are you really saying? That you're not allowed to do it, right? So if you had an equal sign with a slash through it, you're saying that they're not equal to each other. Okay, so we're up to five. Are there more? That's what I'm asking. Are there more? Oh, so we're just going to keep asking each other the same question, see who wins? All right, I'm up. Are there more? Did you say no? And then are there more? I do not. That's it. That's all there are. There are five. Okay? So the less than, the greater than, the less than or equal to, less than or greater than or equal to, and then obviously the last one, two things that are just flat out not equal to each other. Okay? So these are your five inequalities. And then obviously a solution would be anything that makes it true. That's a little bit different than an equation. When you solve an equation, how many answers are there? There's one. That's it. X is 3, X is -2, X is 9, X is 0, whatever it is, there's one. If we put one of these inequality symbols in there, now how many solutions are there? If I said to you X is less than 5, how many things are less than 5? A lot. That's where you're going to build a house someday. Yeah, so how many things is that? How many? There's an infinite number of things. Heck, there's an infinite number of values between 5 and 4. Right? Any decimal that you would give me in between 5 and 4, I could produce one more by just simply putting another place value on it. Okay, so there's an infinite number of values the moment we introduce more than one solution to a problem. And so we'll have to think about that today as far as an inequality is concerned, because if I said to you tonight, listen, your homework is only to do this one thing, list the values that are less than 3. Could you do it? Really? No. No matter what you would do, whatever you would come back, you could come back tomorrow with an entire notebook full of answers that are less than 3, and somebody could always give you one more. Right? I mean, they could do that between 4 and 4.1. Every one of you could give me a new number inside of there if you wanted to by just simply adding another place value. So we'll have to think about how we're going to show that in this type of problem. Now, the addition and subtraction rules for inequality aren't any different than they are for equations. I mean, literally, whatever you do to one side, as long as you do the same thing to the other side, they're still in the same relationship. We're not going to say that they're still equal, because in an inequality, they started off as one side being bigger than the other. Okay, but if you have $10 and Cody has 7, who has more? You do. But if I take 5 from each of you, who has more? You still do, right? You still had more than he did in the first place. So when I take an equal amount from both of you, or I give the same amount to both of you, you still have more, right? So that relationship doesn't change whether it's an equation or an inequality. Okay, so that part's all still true. So with that in mind, solving that shouldn't be a big deal. Like, that's like mentally solving that, I would say. All right, how do you solve that one step inequality? You just simply add 12 to both sides, right? So nothing would change. All right, I'm simply going to add 12 to both sides. The 12s cancel, and C is greater than 77. All right, no biggie. What does this mean, though? To solve and check by graphing. How do you graph an inequality? James, you think you remember? Okay, so now you just took it to a whole nother level. You just went into 2 variables. You gave me an x and a y. But I totally agree with you. If we're graphing it on an XY axis, you've been messing with that calculator, haven't you? Yeah, it starts to shade things on one side of the line or the other side of the line. We'll get there. Not until the last section in this chapter, but yeah, you're on to something with that. There's only one variable here. You have any idea how you graph it? Oh, that's sweet of you. Put a 1? Where would I put that at? Oh, well, that's true. But that, I mean, if I do that, if I put a 1 here, have I changed anything in that statement? Okay, so we'll make that go away. Go away. All right. Big word. You would have missed that. Come on, that was my only trick, and then you just lost it on me. No, you don't like that either. So you just gotta wave it away. See, there it goes. Magic finger. No, come on. It's just that pen right there, the one with the little stars on it. It is magic. It's a magic pen. Now, how do I graph that? Any idea? With the magic pen. Have you ever seen anything like this? Yeah. Listen, you only have one variable, so we only graph on one number line. When we have x's and y's, then we graph on that coordinate plane because it's really 2 number lines. It's an x-axis and a y-axis. They're just 2 number lines. Here, we only have one variable, so we only graph on one number line. Why, though, in these first 2 cases, do the circles not, why are they not colored in? And why in the last 2 are they colored in? Cody, do you know? Okay. So when we say that x has to be less than 5, the open circle implies what? It's not allowed to be equal to 5, but it can be smaller than 5. So why wouldn't I just start at 4 then? That's less than 5. Sure, right? There's an infinite number of values in this tiny little space, right right in there, in that tiny little space, there's an infinite number of values. So we can't just negate them all and decide to start at 4. So we show that by putting an open circle, okay, that's not filled in, and then we point to the left. Will this always be true? That this symbol here and that will match this one and that one match, those two match, those two. Is that going to be the case? Will they always do that? Feels loaded. Feels like a loaded question, right? They will. They will always match as long as you do one thing first. You may, yeah, make sure it's correct. Good call. Make sure that you start with your variable. Make sure that that variable is written first. Like if I took this statement and flipped it, instead of saying, how would you read this right here? X is what? Less than 5. If you turn that statement around, you would say 5 is what in relation to X? 5 is greater than X, right? So it would look like this. 5 is greater than X. Now look, the two are backwards of each other because the variable is written backwards. So if the variable is first, the signs will always match. That is a for sure. All right. If I come back here now and I want to graph that one, maybe not. Depends on whether that's going to move. There we go. How would I graph this? And I don't need to have like a full blown number line. Like I don't need to list out like 60 numbers to graph one thing. Of the 3 spots on there, which one's going in the? What I shouldn't even say that. What do you want to write? Okay, right. That's enough of your number line to know what this thing is doing. Would you graph this with an open circle or a closed circle? And would you point to the right or would you point to the left? Cody, yeah, Cody. What's your name? It is Cody. Open and to the right. So an open circle at 77 and pointing to the right, right? I don't need to put the numbers from 60 to 80 to show that 77 is in the middle here, and we want the things that are going to the right. Like I don't need to get that out of control. Yeah. So if this had an equal to on it, what would change in this picture? You would just close that circle. So you would literally just color that circle in. That would be the only difference. Okay. But in this case, there was not one, so we would leave it open. All right. Take 1 second. Just give me an answer to that one. What do you think that's going to look like? So the math portion shouldn't be anything difficult. I would surely hope. Yeah, you never know though, right? You never know. What you looking at? Oh, you got it in your head. All right. What you doing with that other pencil? Nice. You just holding on to it for like sentimental sake or playing with it? There you go. I like it. Playing around. My fave. If I'm gonna graph that, what does it look like? Kelsey, what do you think? Yeah. All right. You're getting all serious on me. Yeah. Yep. Okay. Yeah. Yep. To the this way. To the left. Yeah, that was very strong how you knew your lefts and rights. You told her the wrong direction. Well, so she listened though. That's good. Yeah. The problem is you just didn't know your lefts and rights. Whoa. She admitted the fault. You don't need to come after her. All right. So as long as the variable is first, the inequality will match. The inequality symbol will match the graph every time, as long as that's true. All right. Pick one. I don't care. Do the one on the left or the right. Tell me what you get. Just do one of them. It doesn't matter which one you choose. Either one should take too long. Kelsey, we'll go with this one over here. This will be on the right. The other one. Actually, let's change this one. There we go. That's too much. That is going to be wasteful on my lead. Whoa. Listen, don't give away Thanksgiving on me yet. You're already talking about Christmas. Yeah, well, it's nice outside, so people. That's a little much. We gotta take those off the. Yeah, it's a little much. All right, so we got to be close there, just based on the amount of conversation. So somebody tell me who you did the one on the left or the right, Declan? Left. What'd you do? Okay, and got an answer of what? -9. What symbol is this right here? Good. Less than or equal to. Okay. So down here, what three numbers? We haven't seen one with a negative in it yet, so be careful about how you write your numbers on a number line for the negatives. What do you have? Okay. -10, -9, -8. Very good. And now you have an open circle or a closed circle, and it points to the left or to the right? Closed and to the left. If you are someone who struggles maybe with reading that symbol, I don't know if that's you or not. If it is, think this way. This will help you. Maybe it'll help you. If you take your left hand, you can make that symbol, right? That will make your left hand will make a less than symbol. Okay? So left hand less than, you can keep that going that way. If that helps you. Less than, left hand. All right? Over here, if you chose this one, you're looking at m is greater than -4. So the numbers across your number line should read what from left to right? What are they going to be, Charlotte? Okay. And then you have an open or a closed circle going to the. Okay. Now, I don't know the answer to this question, but I would not be surprised if somebody in here did not write one of these two number lines backwards. Meaning that I did not ask you to self-incriminate, okay? Right? But if you did, if you put -8, -9, -10, is it written backwards? Yes. Is it wrong? Not really. But if you do that, please realize then that this symbol will not match the arrow because your number line is flipped. So it'd have to go the other way. So be mindful. I mean, if your number line is written backwards, then your graph is going to be turned around. So you just got to kind of think about that. So not that it's incorrect, but it's just a little backwards. Is that any different? Now you got two variables in there. Which one do you move? What are you going to move? You're going to move the 12N. Why, Emily, are you going to move the 12N? Okay. So the 12 and the 13 are like terms. You got to bring them together. Why can't you move the 13? If you move the 13, there'd be nothing there. So you can't move the 13. Moving the 4, what would that do for you? Nothing, because it's got nothing to join. So that would be pointless. So in this case, the only one to move is the -12. 13 minus 12 leaves you with 1. If you don't want to write the 1, obviously you don't need the 1. Graphing this. Yes. What do you got? Okay. So we're flipping the n and the -4. Good. Greater than or equal to? Okay. Good. Good. I often will see kids make the switch here and then forget to turn the sign around. Okay, that's almost as awesome as like opening up your credit card statement and that says you owe $1,000 and you putting a little slash in and saying, nope, you owe me. Like, yeah, you can't. I mean, if you're gonna flip it, you gotta flip the whole thing. Like saying I owe the credit card company $1,000 is like saying the credit card company wants $1,000 from me. We're still saying the same statement. You can't just flip part of it and be like, nah, pay me instead, which would be awesome because I'd buy some really cool stuff and then they could pay me. All right, but that's not gonna work. Now, looking at this one here, do you notice anything different about this problem? What'd you say, Emily? Okay, so there clearly is something weird, not necessarily with the original problem, but these. What in the heck is that? Okay, so when something is written in this fashion, all right. So I'll figure out the right tool here. When something is written like this is what is known as set builder. I can't spell. Don't worry about that. I was like adding two words together. Set builder. I really got to think. Notation. There we go. Hello. All right. So here's what set builder notation is. Essentially, when you talk about having, in this case, an inequality, and we don't talk about having just one answer, we have more than one answer. Okay. Then we're essentially building a set of values. And in this particular case, the set of values is either going to be all the things that are less than or equal to -6, or they're going to be all the things that are greater than or equal to -6. Okay, so if I solve this up here, what in the creation? Here we go. Take both of these. There we go. If I solve this real fast, what would I do to solve it? Move the what? Hunter? Move the 3p. So if I minus the 3p, I would get -6 is greater than or equal to p. Which is which of these choices? Is it A or is it B? Connor? It's which one? I don't agree with you. It's A. Yeah, if you flip this one around, it would match A. Okay. So here's what this means. What we're saying here is that my solution or our set of values contains the following thing. Defined by the variable p, okay, the solution will be all the values. This little vertical bar is read as the phrase such that. Okay, so my variable p will be defined such that it is going to include all the values that are less than or equal to -6. Okay, it looks really strange to write it that way. Would you agree? Okay, it's no different than that. Okay. As you start to get into higher level courses where sets of values become more the commonplace than just one answer, x is 5, x is -2, where you start talking about sets of values that could possibly work, we typically write them with these, like, I don't want to say restrictions, but almost like directions of what the possibilities could be. These two variables right here will always match each other. Okay. What we're saying basically is, hey, here's my variable. That's the restriction on the variable. It has to then be less than or equal to -6. Okay. It could look like this. There's my bad fancy bracket. Maybe it would say my variable is x. Let it be defined such that x is equal to 1, 2, 3, or 4. Saying only allowed to be the values 1 through 4. Nothing else. That may be the set of values that are being built. Okay, so, what is my variable? What is the instruction set, so to speak, for that variable? So in this case, it's just simply all the values that are less than or equal to 6. Okay, so that's this idea of set builder notation. All right, last one we're going to look at today. Take a second, read that. I'm more interested in you being able to set up the problem than answering it. Answering it, this one's not going to be difficult because there's really not much going on. What would my inequality look like? You wish you could buy season passes for 2 amusement parks for $100. That would be. That'd be fun. Did you just say Kennywood? How many of you have ever been to Kennywood? Oh wow. You were 3 the last time you were? You think you got an answer? Okay. So first of all, what does the inequality here look like? Declan thinks he has an answer. Did anybody else have an answer written down yet? No? Okay. So you know that one pass is going to cost you $54.99. She's only got $100 to spend. Do you know what symbol is going to go into this from? What's that? What inequality symbol am I going to use? Good. Less than or equal to. She's only got $100, so whatever I'm going to put over here for the 2 passes is going to have to be less than or equal to what value? To $100. That's all she's got. So what am I going to write over here? What do you got? Say that again. Now you'd almost be dropping 2 inequalities in there on me on that problem. I think you're kind of giving me an answer. Think about what this inequality would read. James, what do you think? Good. Okay. So that would be the original statement that those 2 passes together has got to be less than or equal to $100. Now I agree with you. If we subtract the $54.99 to the other side, it would say that X has to be less than or equal to how much? How much? 45.01. Don't cheat me on my penny. Yeah, I want that penny. In case it's one of those like special, like, Buffalo ones or something, like a wheat penny, I could make a whole bunch of money. So don't cheat me. All right. So X would have to be less than 45.01.
So would you want that answer or
Well, ultimately, then the question here says the second pass could cost no more than what amount. So in that case, we would say that it has to be less than or equal to the 45.01. All right. But this is like at this point, this problem is simple enough that we could look at it and just give an answer, right? But we're going to have to be able to write an inequality in some cases to be able to solve it because it's going to be more than what we can just see inside of our head. All right. Now, before we leave, I just want to leave you with these thoughts. As you get into some of your homework tonight, you want to be thinking about some of those phrases in terms of you being able to write an inequality statement. Okay. So transferring from words into the actual inequality, some of these thoughts, at most, no more than, at least, or no less than, we want to be thinking about those as we get into our homework. All right. Your homework is going to be on a worksheet today. You have about 13 or 14 minutes, so you probably could get some of that done before you leave. Okay.